Hello guys, good day and welcome to our class for today. This is Nobleman Science Tutors Online and we are bringing physics direct to your homes, for your very homes. So please, if this is your first time of visiting this channel, we will encourage you to please subscribe to this channel. Click on the subscribe button, click on the notification button so that when we upload a new video, YouTube will notify you. Then you can reach us through the WhatsApp number that is showing on your screen. And if you have been visiting this channel, you bet me that you have been enjoying our videos and our lectures on physics. So please give us a thumbs up, give us a comment so that you can continue to encourage us. Okay, so please get your writing materials ready so that we can go to our class for today. Today in this class we are going to be looking at heat transfer. Heat transfer, and under heat transfer we'll look at various means of heat transfer of heat energy transfer, and that is conduction, convection, and then by radiation. So guys, if you are ready for the class, let's go straight. Heat transfer, conduction. Okay, so for conduction we know that heat normally flows from a body at a higher temperature to a body at a lower temperature. Okay, so transfer of heat is either by conduction, by convection, or by radiation. Okay, so what is conduction? This is a process whereby heat energy is transferred through a material. The average position of the particles of the material remaining constant. Okay, so for conduction, this is an example of conduction. Okay, so if you hold a piece of metal and you bring the other end close to a candle light or a heat source, in this case a candle light, you will see that heat gradually be transferred from this hot region towards your hand that is colder. Okay, so this material that is carrying the heat towards your hand is called a conductor. Now we have good conductors and bad conductors. A good conductor is a substance that allows heat to be transferred through them very easily. Any substance that allows heat to be transferred through them very easily is called a good conductor. An example is iron, copper, aluminum, silver, and what have you, etc. Why for bad conductors, these are substances that do not allow heat to be transferred through them easily. Example is wood, paper, plastic, wood, and then water. Okay, so these materials, they are called bad conductors or insulators. The fact that they are called bad conductors does not mean that they are not useful. They are very useful in our everyday life. So whether good conductors or bad conductors, all of them, they are useful in our everyday life. Now, according to the kinetic molecular theory, it says that when one end of solid material is heated, the molecules at that end gains kinetic energy and they begin to vibrate with increasing speed. As more heat is supplied or as more heat is applied, the vibration increases, and as the vibration increases, they bump into neighboring molecules more than before, and so energy is transferred to them. This process continues until all the molecules gains enough energy and vibrate about their mean position. In this way, heat energy is transferred. So what this statement is simply saying is that if you look at this iron that is being held close to this candle light, at this particular end, the molecules of this iron here will gain kinetic energy and then they begin to vibrate. As more heat is applied here, the vibration will increase, and then these molecules that are here will begin to bump into the molecules that are close by, and this will continue until the heat will be transferred to this end of this material. So that is what this kinetic molecular theory is simply saying. Is that okay? So you can actually explain conduction using kinetic molecular theory. Okay, so please, I need you to take note of this because you can be asked in your physics examination. So that is conduction. Okay. So as I said before, good and bad conductors, they have their own advantages and disadvantages. Okay, so practical application of good and bad conductors. Cooking utensils are made of metals, which are good conductors, while the handle of cooking utensils are made of plastic, which are poor conductors of heat. So you can see where the bad conductors and the good conductors are useful. Good conductors for the body of your cooking pot, then the poor conductors for the handle, so that you can be able to carry your pot from fire, so that you will not have any burn. All right. Also, for the use of rocks on floors, a tiled floor is cooler than a rugged floor because tile is a better conductor of heat than rock. So depending on the region that you stay, you might decide to use tiles for your floor, or you might decide to use rock for your floor. But you know that when rock is on the floor is warmer. Okay, because a rock floor is a poor conductor of heat, but tile is a very good conductor of heat. That is why once you step on tiles, you always feel cold. Okay, so this is another area of application of a good conductor and bad conductors. Home cooling in the tropics. Okay, home cooling in the tropics. So here too, you have application of good conductors and bad conductors. The use of cloths to keep warm. The cloth that you wear actually is not the cloth that keep you warm, but it is the air that is trapped between the cloth and your body that keeps you warm. We know that air is a poor conductor of heat. Air is a poor conductor of heat. So when you put on a cloth, the air that is trapped between your clothes and your body is what actually keep you warm. The air is a poor conductor, hence wool and fur materials are very good at keeping the body warm. You know, wool and fur material, they are thick, so they will enclose more air in your body, and that is why they will keep you warmer than light clothing, because light clothing will allow air to just flow out of the cloth, so enough air will not be trapped between your body and the cloth. But for a wool or fur material, they will enclose more air between your body and the material. So that's why you always keep very warm when you use wool or fur clothing. So these are areas of practical application of good and bad conductors. Okay, so please take note of these two. These informations, they are good for your external examination, so you take note of them. Heat transfer by convection. Convection normally happens in liquids and gases. Okay, convection does not happen in solid, it happens in liquid and gases. And this diagram here, or this picture here, depicts convection currents. Convection current. Okay, convection is a process by which heat is transferred in a liquid or gas by the actual movement of the heated fluid from the hotter region to the cooler region. What that simply means is that when you bring a pot of water, when you bring a pot that is maybe half filled with water close to your onto your gas burner, the molecules that are at the bottom, they will gradually begin to gain heat, and as they gain heat they will become less dense, and because they are less dense they will rise to the surface, and as they are rising, cooler molecules will come down and take over their place. So this condition continues. That's why it is called convection current. It continues until all the molecules will attain the same temperature. So this is what happens in convection. that okay? Now, according to the kinetic molecular theory, it says that when water is seated at the bottom or below, just as it is in this picture, the molecules near the heat source gain more kinetic energy and vibrate further away from their fixed position and become less densely packed and lighter than the molecules above. That's just what I said now. So the molecules at the bottom therefore rises to the top, carrying energy along. The denser molecules from the top sink to replace those that have risen above. That was just what I discussed too. These molecules in turn get heated, they rise, get heated and rise. Thus, a cyclic motion or convection current is set up until the liquid boils. Convection current is easily set up in gases because gases are lighter. Okay, so that is exactly what I just discussed. That when water is heated, the molecules that are near the heat, they will gain enough kinetic energy and they begin to vibrate, and then they will now move from this position because they become less dense. They will now move up, while the molecules that are up, that are denser, will move down and take over their place. So, and the system continues like that until the water will attain a uniform temperature and then begins to boil. So this is convection current in liquids and gases. Now, convection has application in nature. Even if we don't understand it, it happens, and it is good that you understand that convection actually happens in nature. Is that okay? So that is what we want to look at now. So convection current in nature happens in what is called land and sea breezes. So land and sea breezes are a result of convection current in nature. How? If you live near coastal towns, if you live near a town that has a river, you will definitely experience this phenomena, land and sea breezes. But if you don't live near a riverine environment, you can still even feel land and sea breezes even in your uptown. You can feel it in uptown. So, what is land and sea breeze? Now, what I want you to understand is that in the daytime, when the sun is directly overhead and it is hot, in a hot day, hmm, the land will gain more energy faster than the sea. And because it gains energy faster than the sea, the temperature of the land will be higher than that of the sea in the daytime. And because of that, the air molecules that are close to the surface of the land will rise up. Is that okay? When this molecule rises up, the air molecules that are in the sea that are colder, that are denser, will now come down and take over the space of the air that is in the land that has gone up. So this cyclic movement will continue. So in the daytime, you have what is called sea breeze. Is that okay? You have what is called sea breeze. So this place says that in a hot day, the sun warms the land rapidly than the sea because land is a better absorber of heat. As a result, the air near the land warms up and rises. The cooler air from the sea moves in to replace the risen air. The convection current is complete by the air in the upper atmosphere moving downwards. This cool breeze from the sea is called sea breeze, and sea breeze blows in the daytime. So that is exactly what I've explained, that in the daytime the land gets heater and gets warmer, the air here will rise up, and then the air in the sea that is denser will come down and take over the air, take over the space of the air that has risen up, and this cycle continues. So sea breezes blows in the daytime. What of at night? The reverse now takes place. You know that in the daytime, the gradually in the daytime or at night, the temperature of the environment becomes cooler. The temperature begins to come down, and as it is coming down, the temperature of land will become lower. While sea, because it has high heat capacity, it will retain most of the heat that it has gathered in the daytime. Because of that, molecules of air in near the sea surface at night, they will rise up because they have more kinetic energy. They will rise up, while cooler molecules from the land, they will flow in to replace the molecules that are in the molecules of air in the sea that have risen up. So this circle of land breeze will now blow at night. Okay, so at night the sea retains much of its heat while the land temperature drops considerably. As a result, the sea is warmer at night than the land. Convection current is set up from the land to the sea. The air above the sea warms up and rises while cool air from the land blows in and takes over the place of the rising air. The breeze from the land is known as land breeze. Land breeze blows at night. Okay, so land breeze they blow at night, while sea breeze blow in the daytime. What you need to know is that the region that is the air that is close to the region that is warm and will rise up, while the cooler air will come down and take over the position of the air that has risen up. That is convection current. So in the daytime, you have the sea breeze coming over to take over the land air that has risen up. While in the night, the breeze from the land will come over to the sea and take over the space of the air that has risen up in the sea. And that is why you have land and sea breezes. Okay, so please you need to take note of it. These are questions that you can have in your examinations. Practical application of convection currents is in ventilation of homes. Ventilation occurs when warm air in the house rises and cool air enters through the window. So that is why you open your window. When you open your window, you see that the warm air that is inside your room will go outside, while cool air will come inside the house. Is that not what you experience? So that is convection current. Then also cooling of a car engine by the radiator. This one also takes place by convection current. Okay, so I hope you understand this concept, and because these are what you see every day in your life. Now we'll look at radiation. Radiation is a process by which heat is transferred from a hot region to a cooler region without heating the intervening medium. So which means that for radiation, no medium is required. So you don't need air, you don't need water, you don't need any solid, but this heat is transferred in a vacuum. So let's just put it that heat that is transferred in a vacuum is known as radiation heat. So in this type of heat transfer, no material medium is required. Okay, just like the heat that is transferred from the sun to the earth, there is no material medium that is required. So such heat is known as radiant heat or radiant energy. So we can use a radiometer or thermopile to detect such radiant energy or radiant heat. Okay, so this is what is called radiation or radiant heat or radiant energy. So emission and absorption of radiation by different surfaces. Okay, so this one is very important because this is what we experience on a daily basis. At a given temperature, a dull or black surface will radiate more heat, while a polished or bright surface will radiate less heat. Also, a black surface absorbs more heat than a polished or bright surface, while a polished surface reflects more heat than a black surface. So when you talk about heat absorption and heat radiation, a black body will absorb more heat and also radiate more heat, while a polished surface will reflect more heat than a black surface. Okay, so in summary, a dull or black surface is a good radiator of heat. It's also a good absorber of heat, but a poor reflector of heat. While a polished or bright surface is a good reflector of heat, is a poor absorber of heat, and a poor radiator of heat. Now, this phenomena is experienced on a daily basis. So application of radiation, you know that sometimes when you want to select your clothes, you select your clothes based on the weather condition. You don't want to put on a dark color cloth when the weather is very hot. You know that you'll be feeling sweaty. And you'll be feeling sweaty because the dark color cloth will absorb more heat, right? It will radiate more heat and absorb more heat. So you feel sweaty. So the right cloth for you to wear in a very hot weather is a light cloth or a brightly colored cloth that can easily reflect heat and also absorb less of heat, so that you can feel a little bit comfortable no matter how hot the weather is. So wearing on different colors of clothes on different weather is one area where radiation is applied. On a hot afternoon, it is not advisable to put on a dark cloth because it will absorb most of the heat. A white colored or brightly colored cloth is better because it is a better reflector of heat. Okay, so these are areas where radiation is applied in daily life. The outer surface of a teapot is brightly polished. Why? This will radiate less heat and keep the water inside the pot warm. We know that a polished surface is a poor radiator of heat, so that when you put hot water inside that teapot, the water will not get cold easily. Okay. Also, a brightly painted car is better to use in hot weather because it will reflect the heat and keep the car cool, unlike a black painted car that will absorb it and make the car very, very hot. So this is something that we need to take note of. Factory roofing are painted with bright colors. So in summary, what this is just letting us know is that brightly colored um, clothing, brightly colored materials, they are good reflectors of heat, but they are poor absorbers of heat and poor radiators of heat. So which means that you don't need to use them in you don't need to use brightly colored materials you don't need to use them in indoor weather. Okay, you don't need to use them indoor weather, but for when weather is hot, then you can use brightly colored materials. Then for materials that are dark colored, they are better used in cool weather. Okay, because these materials, they absorb heat and they radiate. They are good radiators of heat, so they are better used in less hot weather. But brightly colored materials, they are better used when the weather is hot. Okay, so please take note of this aspect of radiant heat or radiant energy. Application of radiation, the thermal flask. So we have discussed some areas where radiation is being applied. This time around, we are looking at the thermal flask. This is actually a picture of a thermal flask. So a thermal flask has a cork at the top that is used as a stopper. Then, then there's also a cork at the bottom too. So that's used as a rubber support. Then it has two silver wall. These are the two silver wall. Between the two silver wall, there is a vacuum. Now, each of these features of this thermal flask, they have their own uses. They have their own uses, and these uses are very key. So you need to take note of them. So the thermal flask is used to keep water warm or cold for a long time. And look at the features of the thermal flask. One, it has a double wall glass with vacuum between the walls. That's what I've said. So what is the essence of the vacuum? We know that the vacuum uh, radiation heat passes through a vacuum. Okay, so radiation heat passes through a vacuum. Alright, so this double wall that is here is used to prevent heat loss due to conduction and convection. Heat convection current requires a material medium, so which means that the heat cannot pass through this vacuum wall through conduction and convection, but heat can pass through it through radiation. Okay, so this vacuum wall is to prevent heat loss due to conduction and convection. Then this silver wall, it has a double silver wall. The double silver wall, they are meant to reduce heat loss due to radiation. You know that a silver wall is a poor radiator of heat, right? It's a poor radiator of heat, but a good reflector of heat. So which means that the silver will prevent heat loss due to radiation. Then it has insulating cork at the base to prevent heat loss by conduction. That is this one. Then it has a cork at the top. This one prevents heat loss due to convection and conduction. So these are the features of the thermal flask that it is good that you take note of them. Please take note of these features because these are questions that are normally brought in your WAEC examinations. Okay guys, so this is all about heat transfer. I hope you have learned a lot from this particular topic, and we are going to stop our class here for today. But before we leave, please, if you have not subscribed to our channel, please subscribe to this channel, give us a like, click on the notification bell so that when we upload a new video, YouTube will notify you. Please, you can also reach us through the WhatsApp number that is showing right on your screen. This is Normal Mind Science Tutors Online. We are bringing physics direct to your very doorstep. So thank you for your time. Invite your friends to come and enjoy this physics lecture online. Thank you so much. We see you in our next class. Thanks.